All right, so the very first thing we're going to look at is those practice problems that I mentioned. So these are available on Canvas. So you're going to go to the Canvas homepage for SI and then to modules, and then you will see something like this for week 11. So this is where all of yesterday's material was. This is where today's will go. And then finally, we also have this page that has a whole bunch of practice problems on it. I have 2 that I still have to finalize, but the rest of them are all done. And these are not required. Just one student asked me if I could create some, so here they are. And the one that we are going to be taking a look at is this one called value swap. So what you're going to do is you're going to create a function called swap strings that takes in 2 string arguments. And after calling the function, you are going to have the 2 values that you sent it are going to be swapped. So you have some starter code here. So I'm going to take that and put it in my text editor. And then we will go from there. So that's the starter code. And the basic idea with swapping 2 variables is this. So you have 2 variables and your job here is to swap them. Well, I have 2 boxes here and we're going to think, how can we swap these 2? Well, if I take this one and I go ahead and put its value over here, and if I go back and try to swap it backwards, I have just created 2 identical variables of user num2 when I was intending to create a user num1 going over into user num2 like this, and then user num2 going to user num1. This is their values. We want them to swap. But we just tried that moving the boxes around, and that didn't work, and it will never work unless we have a temporary variable. So what the temporary variable does is it's a variable, nothing special, just a variable is the same data type as both of these. So what you do is you take either one, it doesn't matter, and you take its value and you assign it to temp. So we're going to take this value and put it in temp. Now, what you do is you take the other variable and assign it to the first one. So the user num2 goes to user num1. And then finally, we're going to take our temp variable and assign it to this one over here. And then we were able to swap them. So if we go back to the original, we had user num1 over here and user num2. And I go back to the new one, we have user num2 over here and user num1. So that's the idea with swapping variables. So now we're going to actually try doing that in a code. And ask me if you have any questions, feel free to ask away. All right, so here is our starter code that we were given. So we have a comment here that says define our function there. And we have another comment here to say that we're going to call our function here. So I think a good place to start, hey Ventura, is to do.
Hey, how's it going?
Hey, how are you? We are looking at a swap function right now. So we are talking about how when you have 2 variables, when you want to swap their value, I think you probably did. You might have. I wasn't there. Did you guys already do this on Monday? I didn't go to Monday. I was sick.
Yeah, but we did it with numbers though, not with words.
Okay, here, we'll really quickly review it and hopefully it won't take that long then. So what we're going to do is we are going to define a function called swap strings. Of course, the one class I missed, I repeat. All right, so we're going to call it swap strings, and then we're going to have 2 string parameters and string. So what is wrong with what I've written so far? Besides the obvious braces. Not quite. So we have 2 strings, right? And we want to swap those. So when we call our function, we're going to give it this value and this value. So we do want those to be strings, but there is something that is pretty wrong here at the moment. All right, let's keep coding and we'll see if we can figure it out. So now we're going to do the swap sequence. And since you guys already covered it, I'm not going to go into too much detail, but we are going to create a temporary variable that is the same type as the two that we'd like to swap. So we're going to say string temp. And this is going to be assigned with either of these. It doesn't matter which one it is. Then we're going to do string one. I'll just call it that one. Then the next step in our swap sequence that we just took a look at with those boxes, and assign it with the value of string 2. And then finally, yes, and then we are going to take string 2 and assign it with the value of string 1, actually temp. So this is what we just saw with those boxes here. So if we wanted to swap the numbers, we have temp. We have an extra variable called temp. And if I wanted to swap this usernum2 with usernum1, these two swap, I have to have this extra variable because I need somewhere to put this stuff. I can't just swap them without that extra variable, or else they're going to get overwritten. So what you do is you take one of them, doesn't matter which one it is, you store it in temp. So we're going to do that with the boxes, put that in temp. Then what you do is you take this one and you assign it to there. And you put that here. And then finally you take what was the previous temp variable and put that here. So it's like this circular cycle of swapping these variables. And then we have swapped them. So that is the equivalent of what we have just done in code. So just going pretty fast, since you guys said that you already did this, we're going to call our function. So a function call, who can give me the syntax of that?
Swap strings.
Yep, we're going to give it the function name. Perfect. So function name is swap. And then I'm going to call it with the arguments. It really doesn't matter which one I put in first. And then notice we aren't actually doing anything with this function exactly. We're not printing it. We are not storing like the return in a variable. We're not doing anything here. So we're not really doing anything with it, but we're expecting that these two variables are going to swap places. So there's two big mistakes in this function. Who knows exactly what they are?
We need a void.
Exactly, we need a void. Because a void says we're going to return nothing, and that's exactly what we want to do here. And I'm going to save this right now. And let's see, here we go, no errors. And when we run it, before swap, we have hello world. String 1 is hello world and string 2 is hello world. But then after swap, we called the swap function here. This is the after the swap statement. What we should be seeing is world hello, but we didn't. So why is that? This is something that we talked about yesterday at the very end.
You need another return function.
We could try and do a return. We could say that this is type string. We could return. But what would I want to return? I could return string 1. And then I could say, okay, the value of string 1 is going to equal this. So basically, when you swap whatever was in string 1, you're going to return that and assign that to our string 1. And if we tried doing that, let's see what we get. Well, now we get world world. So we returned one thing here, and then we took that stuff and put it in string 1. So our swap function did technically do what we wanted it to do. It just didn't swap both of them because we only returned one thing. So who can tell me, can we do something like this? Can we return two things? That's kind of what we want to end up doing here, right? We have a function that is editing two values. All right, so you're saying that we should do another call to the function. And like that, should I change this return statement at all, or is it fine? What if I did like another return statement? Like that. Let's do that. All right, so now if we do this, I am missing a semicolon. Thank you. All righty. There we go, no errors. And we have still world. Well, why did that happen? Well, yesterday I told you guys when we head up to a function, we're going to send this stuff there, just the usual function stuff. Then we're going to execute all of our statements. But what happens the very first time we see a return statement, we literally return to the function call. And what's going to happen here is this second return statement will never, ever execute because it's below the first one. We're still going in order of the lines all the way down, unless we have any if statements or like loops that tell you to do something else. But we're still going in order. And as soon as you get to return, you are just returning right back to the function call. So that's what happened when we did that call. And when we do this call, we're sending this up, we're sending this up. And what's happening is we're going to go down and we're going to do the first return statement and then immediately return back. So both times we returned string 1. And the interesting thing is we can only return one thing in a function. Only one. So there are times like this where we technically want to take 2 values from the function. But with return statements, that is not possible. And the trick to doing this is the difference between pass by reference and pass by value. This is what we talked at the very end of yesterday when we were sending these strings to our function. And we noticed that when we did stuff to them, just like we're doing here, the function is not changing them because it's sending a copy of the string to the function and then is doing some stuff with that. And then it's sending the result back, but it's not messing with the originals. But what we wanted to do is actually to edit the originals. So then when we call the function, the original arguments that we send it will be mutated a bit. So who remembers how we can change it to a pass by reference function?
You do a cout.
A cout here? Or a cout like in the function?
Good question. I forgot if it was inside the function.
It's okay. Here, this is actually a good point that I did want to bring up anyways. So I am going to just run this code real quick. So look at that. We got a ton of errors and this looks very scary and it looks terrifying. But I wanted to tell you why this didn't work. And it's a very important concept. So you have a function right here that is type void, right? So you're basically saying that your function is going to return absolutely nothing. So usually like when we print a function like pow or fabs or one of those guys, they result in a value, right? When we look at this function, it results in its return value. Well, if it were like fab or abs or absolute value, all that stuff, it would result in a value and then we can print it. But the difference with a void function is it doesn't result in anything. It has no return value. That's what we're specifying when we say void. So basically what you're trying to do, this doesn't have any value here. So you're trying to print nothing. And the compiler is getting obviously very upset about that. So you cannot print a void function because a void function results in nothing. Just a little side tangent that I thought might be important. Okay, so pass by reference is really easy actually. Once you know the syntax, it's not a lot of code to change. All we have to do, if we want to make our code, our parameters pass by reference, we just add an ampersand onto the end of the onto the end of the data type. So we could have 2 pass by reference parameters. We could have all of them pass by reference, all of them pass by value, just a few, it doesn't matter. Just whatever one that you do want to change the original value in the argument, you just stick an ampersand at the end and that's it. Does that make sense? All right, cool. I guess we spent a little bit more time on that than we were planning on, but hopefully now you can see the benefits of a pass by reference because we didn't talk about really exactly why that would be beneficial yesterday. So I wanted to bring that up. And for those of you who came in a little late, I wanted to let you guys know that we do have a bunch of practice problems on Canvas. We just completed the one called value swap, but there's a bunch here and the answers if you did want to do those to get more practice. Okay, back to stuff that is not really functions. Actually, this is kind of functions. I have a few more useful resources for you guys if you do want to get more practice, because I know we're getting further along into the semester. If you're feeling like you're not getting enough practice with coding, we can always edit how we do SI if you want to do a lot more practice stuff. or there are these 3 websites here, which are going to give you a bunch of practice problems like I have created, but like a lot more than I could ever create. So this one is called Eat a Bit. And what happens is when you open it, you'll be taken to this website. You can change it to our language, C++. And then you can change the difficulty. And then you'll have all of these potential problems. And it will give you some instructions just like I do. And then you can code it here and it will check your code for you. So all of them kind of work like that. I just thought I would mention those if you did want to take a look at them. Of course, not required. Okay. Any last minute questions on functions before we do our vector stuff? Because that is what's up next. Alrighty. Vectors it is. All right. So thus far, when we have seen variables, they're like boxes, right? We have this variable, this container, and we can put something in it. We could put in an int, we can put it in a bool, we could put in a string, we can put all this stuff in this thing called a variable. But the very interesting thing about variables is they have a capacity of 1. We can only store one thing per variable, right? When we like reassign a variable value, we're not like adding another part of this variable, we're reassigning it. Well, wouldn't it be nice if we could have a bunch of data or like one kind of single variable that holds a whole bunch of related stuff? That'd be pretty cool, because right now all of our variables can only store one thing. And the very cool thing is we have this thing called a vector. So a vector, you can think of, if you're thinking of variables as boxes, you can think of a vector as a train. So your vector is like a series of variables or a series of these boxes on the train, and they're all related to each other in order. And each one of these boxes in your vector can hold one value. Each of the boxes is technically termed in a vector. Each of the boxes are called an element. So basically what you end up having is this sequence of all of these variables in a row that are related to each other. That kind of sounds a little similar, right? It kind of sounds like a string. In a string, we have a sequence of characters in a row that are related to each other. So you have a string like this, and your string is a sequence of characters that are all related to each other in a row. And this is actually really, really, really similar to the concept of a vector. The only main difference is a vector has all these different special functions that we can apply to it. And the things that are at like each index, like the cars, I guess, if you want to call them that, each of the little boxes that the things are stored in, we can store more than just characters. We could store ints, we could store strings, we could store characters, we could store doubles, bools, whatever we want. If it's a valid data type, it can usually be stored inside of a vector. So a little more on that. The vector also has a size, just like a string does, and we can also identify each part of it with an index. So let's take a look at writing or defining vectors. So when we want to create a vector, we have to do 2 things. The first thing that we have to do is include the vector library. This is done using #include_vector, just like you do #include iomanip, #include iostream, all of that stuff. Whenever we want to have vectors in our program, we have to make sure that the compiler will recognize that vectors are a thing. In order to do that, you have to include vectors. All right, so now that we have vectors included in our program, we are free to do whatever we want with them. So to create a vector, this is the standard syntax. It looks a little bit like a variable declaration, and it is kind of similar, but there's a few key differences. So usually when we create a variable, we have a data type followed by an identifier. Here we have a little bit more than that, but not much. So we have the keyword vector. This is what tells your compiler, okay, whatever I'm creating here is going to be of type vector. Then you have to tell it, what do I want to store in my vector? Do I want to store ints in my vector? Do I want to store strings in my vectors? Do I want to store characters in my vector? You have to tell the compiler what data type of data that you're going to be storing in this vector. Because with vectors, you can only store one data type. That is one limitation with them. Just like strings, it's all, a string is a sequence of characters, but it's all characters, right? So when you have a vector, you have a sequence of data, but all the data has to be the same type. And then finally, the last thing to note is you have to give it a name, just like any other variable that you're creating. So thus far, any questions on vectors? Vectors are like a list, and at every index of the list, you have a different thing, just like a string. So if you want to relate them to something that we have previously learned, think of them kind of like strings. They're not exactly strings, but similar. Okay, so now we're going to move on to a little bit more complicated vector declaration. So this is the very basic one, but the thing to note about this is you're creating an empty vector. There's nothing in it, right? There's nothing here. So you're just saying to the compiler, okay, there's a vector here, but I have nothing in it. But what if you want to predetermine some stuff in your vector? Just like when we say like string is given like some sort of value here, right? We can give it a value initially. We can declare it and initialize it in the same statement. We can do the same thing with vectors, and there are 3 different ways to do that. So this is the 3 different ways. This is probably the most common vector declaration that you will see, but I wanted to show you the other 2 as well. So for this one, we do the exact same thing. We tell the compiler it's a vector, and then we tell the compiler what is getting stored in our vector. Is it strings, is it ints, is it characters, et cetera, et cetera. So that goes in these brackets right here. So for this vector, we are saying that it's type int. Then we give it a name, and now we have an assignment statement. That looks pretty familiar to us. But then we see this. So when we declare a vector and assign what are called elements to it, we put those elements in brackets, and then each one is followed up by a comma. And then at the very end, when we're done adding elements to it, we put a semicolon, just like every C++ statement. So in my vector 1, it's going to have a list of elements that contain 2, 8, 1, 183, and 13. So that's what vector 1 is going to contain. And those are all accessible by indices, and we'll see that in a bit. The second one is this one right here. And for this, we have the exact same stuff over here, but we have in parentheses a 6. So what this does is when you have one number in parentheses following a vector identifier, it's going to create a vector which is of length this number. So for vector 2, you're going to have a vector that has 6 elements in it. So 6 things, 6 boxes, right? 1, 2, 3, 4, 5, 6 are in your vector. This is what's in your vector. And at every single index, every single one of these elements, when it's of type int, is going to have value 0. It's basically going to just give you a vector that is of size blank, this thing right here, and put just some random stuff in there. In int's case, it's going to be all zeros, and strings, it's going to be empty strings, just like the empty version of that data type, if that makes sense. And finally, the last one, that one you'll actually probably not see very often, so don't worry too much about it. Just wanted to talk about it. And the very last way that you can declare a vector is by using this syntax. So the first argument right here defines the size. So it's still size 6. We're going to have 6 elements. And the second argument here defines what each of those elements is going to have a value of. So in this case, every single one of these is going to be a 2, an int 2. So we're going to have a list of numbers, all of which have the value of 2, and specifically 6 2s. These 2 probably won't see very often. This one, that's the one that you're going to want to memorize and get down. Any questions on that before we start? Because I'm going to have you guys write a vector declaration in a second. All right, feel free to jump in because I know this is a lot of new stuff. Okay, so what we are going to do is I'm going to come over here and open the next program that we're going to take a look at. And what we are going to do is I'm going to have you guys help me declare a vector that is going to have the following data in it. And it just has a bunch of different food. So I want to just create a vector and it's going to have these elements in it. How would I do that?
Would it be vector string?
Yeah, sounds good. So we're going to say, okay, we want to create vectors. We're going to telecompiler that. So we're going to say vector. And then in these angled brackets is where we put the data type of what's going to be inside. So we're going to say string. And then James said that we are going to have to include vector. You are absolutely correct. So we're going to say hashtag include vector. All right, perfect. So now we're allowed to do this. All right, so it's going to be of type string. What else?
And all that's going to equal to the ice cream pizza salad pumpkin sandwich.
Perfect. We do need to create an identifier because whenever we create a variable, it has to have a name because vector, like a vector is a variable, right? Like just we have a string that's a variable, an int is a variable, a vector is a variable. So you have to give it a name. So I'll just call it food. Very descriptive of what it is. All right, so now we had 3 different syntaxes, actually 4, that we could do to create a vector. The first one is just this. This would create an empty vector with nothing in it. The second one is where we gave it a size. This would create 6 elements of a vector that are just empty strings. Not exactly what we want to do here. We could create 6 elements and tell all of them to be ice cream. Also not exactly what we want to do here. So we are going to use the last one, which is where you have an assignment statement. So you're going to say food is going to be assigned with the value. So this stuff goes in curly braces. And then you are going to put it in double quotes, because remember, double quotes is a string. So when you are creating a vector, it's like a list of this data type. So you have to follow the data type rules still. So whenever we want to say it's a string, we are going to put it in double quotes. And all of these guys are separated with commas. All right, and finally, a semicolon at the very end. So that is how we'd create a vector with this data. Any questions on that? All right, if not, we are going to start talking about what can we do with these vectors? Because now we just have a list and there is a lot of stuff that we can do with them, but there is a very specific syntax that you have to use. So very first thing that we're going to talk about with vectors is .at. As we know, when we use strings, we can use .at to give you a specific character at a specific index. For example, if we had this string called string1, and we said the string .at2 is going to give us the value at index 2. So this would return a D, right? Not too bad. Well, the very cool thing is with vectors, we have the exact same function. Take a look at this. So here I have 2 vectors. This is the one that we have in our program. I'll just switch it to food so it matches. And we get to use the .at function on a vector as well. And it works the exact same way. What we do is we have our vector and we say that vector .at a certain index. And look at this, our indices start at 0. Every single time in coding that you're going to see an index, it's going to start at 0. And it works the exact same way. So at each index, you have one singular element. And when you say vex food .at 2, and that would return right here, salad. If we said vex food .at, I don't know, 5, that would be out of bounds. Actually, ignore that. 1, there we go. We'd return pizza, and et cetera, for every index in the vector. And this is just another example showing it with a different data type. So you can have a vector of strings. So this would look, of characters. So this would look a little bit more familiar to you. So you'd say vex letter at index 3 would give you an E. So hopefully not too bad. We're going to see that working in our code next. So what I want you guys to help me do is I would like to print out pizza, or actually, you know what? We do that a lot. Cookie. Let's print out cookie from our vector. How would I do that? Just cookie, and that's it.
Be vector dot at food.
Like this. All right, so remember something real quick. When we have a string, and we are going to just call it stir, and I'll give it, if I wanted you guys to print me out the O from cookie, what you would do is you would say stir dot at, and dot at 1, right? That's what you do if you wanted to print out the O. Well, the vector functions work very, very similarly. So notice that when we say stir, it's the name, right? We say the string, the name of it, the identifier, dot at whatever index. So it's the exact same thing. So in our particular case, our vector is called food. So we'll say food dot at, and in the at function, we give it an index, right? So that's exactly what we're going to do here. And an index is a number. So we are going to count 0, 1, 2, 3. So we should give it index 3. And now we'd like to print that. There we go. So does that make sense with dot at? Because we're going to run that next. Any questions, feel free to interject. So one thing that I found, it was really weird. When I was trying to compile a code with vectors on my Mac, just the regular way, when I said G++ vector.cpp, I got a whole bunch of errors. And I have been using vectors up. There we go. That needs to be fixed. Now, if I compile it, I'll still get a whole bunch of errors. There we go. 1 error. And the truth is we didn't do anything wrong here. And I think this is something with the version of C++ that is installed on my Mac. So what I had to do is I looked on Stack Overflow and I just searched this exact error. This is a tip for you guys. If you ever come up with weird errors and you have no idea what they mean, you can reach out to me, or you can go to Stack Overflow or just Google and you would just search the error. And when I did that, I got back that I'm probably running the wrong version of C++ on my Mac. So if you also have a Mac, this might be an issue for you, maybe the Windows people as well. And the fix was to do G++ followed by negative standard equals C++11. So this is the version of C++ that we need to run. We need to run 11 or higher. So when I do that, then I have no errors. So I will put that command in chat in case any of you guys come up with the same error on your own computer. And for the Windows people, it might be a little different, but Stack Overflow is great. So that is that. And there we go. Exactly as expected, we printed out the food at index 3. So that would be cookie. All right, perfect. Next up, we are going to take a look at another vector function, and this one's going to be very familiar. It is .size. I told you guys we would eventually come to another type of data in which we are going to end up using .size, and that is when your difference between .size and .length matters. Well, guess what? We are here. So a little backtrack. We know that when we have a string and we call the size function on it, it returns the number of characters in our string. So this one would return a 6 because we have 6 characters in coding. So now we're going to take a look at our vectors again. So the vectors also use the .size function. And in a vector, when you use the .size function, it returns the number of elements in your vector. This is not the same as the number of characters, because if we were to look at the number of characters in our entire vector, we'd be counting I, C, E, C, R, E, A, M, the space, the P, I, Z, Z, A. It's not that. It's looking at the number of elements, so the number of boxes that we have in our vector. And in this particular case, when we would call the size function on our vector, we'd return what? What would we return? Size gives us the number of elements. How many elements are here? 5. Good job, you got it. Because we have 5 elements in our entire vector. All right, so this is where the difference between size and length are very, very important. So just because our functions have the same name as the ones that are used on strings doesn't mean that we can use all the same things interchangeably. So length is a specific to a string function. I know I've been relating vectors to strings. They are technically different. They're similar. They're conceptually similar. However, they are a different type of data. So vectors can use the dot size function. However, they cannot use dot length. So careful not to get that mixed up, or you will get an error, and we'll take a look at that. So next, we are going to print out the size of our vector here. All right, so to do that is the same syntax as we would with a string. We are going to say the identifier dot size. That's it.
I got a question.
Go for it.
How come your when you printed out cookie on the compiler, it has like a percentile sign?
Ah, yes. So what's happening there is notice how before I added this end line, I actually didn't save it with the end line. I saved it like that. I just printed out cookie.at or food.at 3. And what it did is it printed that directly to the compiler, but I did not include an end line after it. So what happens is, if you notice on my console over here, I have all of these percent signs all over it. And this is on my computer, my command line prompt. So what happened was, since I didn't put an end line at the end of cookie, the command line prompt managed to jump up there because I didn't separate it and tell it to go to the next line. So if I were to run this with an end line and save it, there you go. See, now there's no percent sign. So that's nothing with the code. That's just my terminal.
Oh, okay, thank you.
Yeah, of course. All right, so next we are going to print out the size of our food. So to do that, we just say the name food dot size, and I'll stick an end line on it so we don't have the same problem. And a semicolon. Not too bad. And running that again, the size is 5, just as you guys said. So very nice. Real quick, if we were to accidentally get length and size mixed up, if we did call length on a vector, this is what would happen. It says that there is no member function named length that is known for vectors. And this is 100% true. There's no function called length that we can use with vectors. So not that bad of an error to read. So yeah, not too bad here. So now that we've gotten some experience with those functions, we are going to probably spend the rest of class doing this. We are going to do a programming activity in which we are going to mimic a magic 8-ball. So you might have had one of these when you were a kid. Basically, how it works is you ask it a question and then it will randomly generate an answer. So we are going to mix up our random numbers and our vectors together to recreate this. So I'm going to copy this to my desktop so we don't have to switch back and forth like usual. And we will get started. All right, so in a magic 8-ball, there are a specific number of phrases that your answer can result in. So what I have done with those, so you guys don't need to see me typing for 5 hours because you guys know it would take me that long. I have put all of those inside of a string vector. So hopefully that is not too quick to do that. So I've just decided that I'm going to make a vector. It's going to be of type string. I have named it phrases. And then I have my brackets that come and connect down here. And I have just put in each one of these phrases into that vector separated by commas. You could put all of these on one line. However, we tried to stay under 100 characters in C++, and that would go way trailing off the side of my text editor. So I have just put a line break between them. And you can do that because the end of the statement is right here, right? We have that semicolon. The semicolon ends the statement, not the line breaks. So we can separate it like that. So it's a little easier to read and takes up less number of characters per line. So if that is all good and you don't have questions on what I have done here, our job is, firstly, we are going to just take input for a question. You see how it says ask a question and then the user can give input. So that is the first thing that we are going to do here. And to do that, we are going to just do a basic input statement. So I'm going to create a string input, and I will just do a get line because you see other spaces. So we're going to do get line and sin and input. So now what I want you guys to do is figure out how I could randomly print one of these phrases from the vector. That's all we're going to do actually, is we just need to randomly pick one and print it to the console. So what would you do?
Well, we call it, right? We call the vector.
Yeah, so we'll say phrases. And what function do we have that can give you one element from our vector?
Dot at.
Perfect. And then in parentheses, we are going to give it an index. However, to make this like the original 8-ball, we are going to do this completely at random. So we need to randomly choose one of these. So do you guys kind of remember how we were able to generate random numbers a bit ago?
Rand.
Yeah, so when we want to do random numbers, we have to do a few things. The very first thing that we have to do is include a specific library. And what library is that? Do you guys know? And if not, no worries. I hardly remember this one because we use it so infrequently. It is the C standard library. So it's C std lib. So we're going to include the C standard library. Now what we need to do is generate a random number. And from what range do we want our random number to be? Looking at this, I can tell you, I'm pretty positive that there's 20 elements in here, but you guys shouldn't need to know that. But if that helps, there's 20 things in here. So from what range do I want to generate a number?
0 to 20.
We are going to do very, very close. It is 0 to 19. Because remember, our indices, those guys start at 0. However, if we went 0, 1, 2, 3, a bunch of them, the last one would be 19 instead of 20 because we're counting from 0. So the size is 20, but the last element in it is 19, just because we start counting from 0. So we are going to need to generate a number between 0 and 19. So how could we do that? Because this number that we generate, we're going to use as our random index. So I have a variable that I've created for that, and we need to just assign it with a random value. And if you don't remember, no worries, I won't keep you guys waiting and I'll let you know where it is. All right, so whenever we want to generate a random number, we call the rand function, and that looks like this. It's like that, rand stands for random. And what happens when you call the random function, it is going to give you a really, really, really big random number, huge. And it's going to be a positive number, it's going to be a whole number, and it's going to be random, but very, very big. So if we were to just see out randnum, you will see this. Save that, and I will run that for .cpp. Oh gosh, what did I do? Hang on, give me a second to figure out. I don't know if I'm mixing up errors from last time. No mention. Oh, right. We did not complete the .at statement, which is why it's upset. We left that there, and I did not delete it before running. There we go. All right. Luckily, not a big issue. All right, there we go. So we have a really big random number. And this number is not exactly in the range that we want, right? This is a lot bigger. So what we have to do is we need to scale it down to the range that we want. And we're going to do this using the modulo operator. It's been a long time since we've seen it, but it's the one that looks like the percent sign. And if you remember, what this does is it gets the remainder of integer division. So when you have, and I'm going to try and not mess this up again, like usual, a number, and we'll just call it 24. And I'm going to divide, actually not 23, a 4 into that. Well, what's going to happen is I'm going to do 4 times 6, so that is 20. And I'm going to be left with a 3, right? Well, the interesting thing is when you take a number.
Where's 24?
Wait, yeah, you're right. It's 5. Thank you. There's no math, not my thing. It's 5. That's not really mattering. We're looking at the remainder, but thank you very much. 4 times 5 is 20. Thank you. Math is, that is exactly why I have this here. Not good. Anyways, back to C++. When you have a remainder of 2 numbers, and this number is positive and bigger than this one, well, what remainders can you get? What is the range of remainders that I could get dividing any big number by 4? If it's positive and it is greater than the 4.
From 0 to 3?
Exactly. You can get a 3. You could get a 0 if 4 goes in evenly. You can get, say this number was 21 right here. We would end up with a 1. If this number were 22, we would end up with a 2. And then if we went up to 24, we would do my original mistake here and go into it 6 times, and we would have a remainder of 0, right? So if we have a big number, if x is greater than 4, and we divide it, it can result in remainders between 0 and 1 less than this number. So we can use that to our advantage using the random function. So if we randomly generate using rand a random number, which we know is going to be bigger than the range that we want to scale it down so we have a range between 0 and 19. So we're going to do that using the modulus operator, because we know that if we take a big number and we divide it and we get the remainder, it's going to be between 0 and 1 less than the number that we put here. So what number would I want to scale it with to get the range between 0 and 19?
20?
Exactly. We want to scale it with 20 because if we take a really big number and we divide it by 20, the potential remainders that we could get from that division is going between 0 and 19. So there we have scaled our random number. So now the last thing that we have to do is we're going to make use of that. So now we have a random number and it's going to be between 0 and 19. And what we do here is we're going to just call our vector dot at that index. And what we should expect is to get a random phrase back. Alrighty, so we're going to get out of this and I will rerun it and gonna just, there we go. Outlook did not look good. Awesome. And if we run it again, Outlook does not look good. Well, here the output really does not look good, does it? We are not getting random numbers, really. We're getting the same one over and over and over again. Well, I can tell you that this equation is correct. However, we missed one thing in the random number generation syntax. And if we don't do this one thing, you won't get truly random numbers because it's going to just keep giving you the same one over and over and over again, no matter how many times you run it. Do you happen to know what this is? Do you put something in the parentheses here? Not quite. The rand function takes no parameters, but we do have to call one more function. And this is, if I remember correctly, it's been a long time, it's going to be srand. So we're going to seed the random function. And what you do is you call srand at the top of your main function. You only have to call it one time. And what this does is it will make it so your random numbers are based off of the time. So the time is constantly changing, right? So your random numbers should actually also constantly change. So this is how they decide to do it. So we say srands, and then you do time 0. And this is just a function call, and that is all that is. It will just make it so your random numbers are a little bit more random. Really hoping I typed that out right. All right, no errors. There we go. So that made it so our random numbers are not going to repeat as much as before. And now you have a cool little program that you can make some important life decisions with. So that's great. One last thing on this program, because we are almost at 2:15. I did want to let you guys know when you want to generate a random number for all indices in your vector, instead of counting them like we did, what we could actually do is make use of our size function, right? Because our size function is going to give you the number of elements in your vector. And that's exactly what we want to scale rands with. So you instead, if I had like a whole bunch of elements, maybe hundreds, and I don't want to count them, what you could do is you could say phrases dot size. And this is going to result in 20, just like before. It's just another way to do it, so it's not hard coded. And yeah, that is it for this program. Any questions on it? So in the live SI meeting, we ended up going a little over time and also stopped the recording for a bit when we were discussing the end of SI. So I'm creating an additional portion, which is going to just recover exactly what we ended up talking about. So not much, but I figured I'd stick it in here. So the last thing that I wanted to mention to you all is that on our SI Canvas page, if you open that up and go to week 11, which is the week that we are currently in, all the way at the bottom, there is something called practice tests from April 6th. And if you open that up, there is a practice test. This is just something that I had from last semester's SI, and it is covering stuff that we had talked about recently. So I figured I would share that with you all if you wanted to take a look and test your knowledge on for loops, vectors, and functions. It, of course, is not required, much like anything else from SI. And just to clarify, you do not have a test coming up. This is just something that I had on hand. So I figured I would share it with you all. And that is it. Thank you so much for watching the video, and I will see you all next time. All right, bye-bye.